Hello students, so today I'll be teaching you about the physics of motion. Our learning targets for today are that we'll be explaining and predicting different patterns of motion of objects. We'll also be able to construct and interpret graphs of position, velocity, or acceleration versus time. So, our do now. These are some questions for you to think about. What is motion? If I were to drop a feather on a stone from the same height, which one would land on the ground first? Now think about this question in the context that there is no wind or air resistance. Which of these two items do you think would land on the ground first? So for today, we have some key terms and definitions for you to remember throughout this lesson. First, distance. Distance is a scalar quantity that refers to how much ground an object has covered during its motion. Next, we have displacement. Displacement is a vector quantity that refers to how far out of place an object is. It is the object's overall change in position. Two important definitions here are vector quantity and scalar quantity. A vector quantity is a quantity that has both magnitude and direction. A scalar quantity is a quantity that has magnitude only. Other definitions for you to remember are speed. Speed is the distance traveled per unit of time. It is how fast an object is moving. Also, velocity. Velocity is a vector quantity that indicates distance per time and direction. Acceleration is a vector quantity as well that is defined as the rate at which an object changes its velocity. Force is a push or a pull upon an object resulting from the object's interaction with another object. And lastly, free fall. A free-falling object is an object that is falling under the sole influence of gravity. Now, here's an exercise for you to do. Scalar versus vector. Create a chart and place these items in the categories of either being a scalar or a vector quantity. Take a minute to do this activity. So some of the scalar quantities here would be distance, speed, and time. The vector quantities here would be displacement, acceleration, velocity, and force. When we talk about motion, there are two main kinds of motion: linear motion and uniform or accelerating motion. Linear motion is the motion that is natural to an object moving in a straight line. Some key terms for linear motion are distance, speed, and time. On the other hand, we have uniform motion. Uniform motion is a motion that occurs as a result of an unbalanced force being imposed on an object. Some key terms for uniform motion include displacement, velocity, acceleration, force, and time. Let's try model problem number 1. An object moves from point A to point B to point C, then back to point B and then to point C. Part A. Find the distance covered by the moving object. So let's go back to the question. Object moves from point A to point B. So object moves from point A, point B, to point C. Okay, we got that. Now, from point C, where is it going? Back to point B. So, from point C, comes back to point B. And then back to point C again. So we have 3 different movements going on here. From 0 kilometers to 9 kilometers. Then from 9, we go back to 5, and then from 5, we go back to 9. So let's count how much distance this object moves. So from 0 to 9, that's 9. Okay, so 9 plus 9 to 5. Let's do the subtraction. 9 minus 5, 4. Let's add 4. And then from 5 to 9 again. That's 4 kilometers. So now we have to add this to get the distance. So 9 plus 8 is equal to 17 meters. So the distance this object travels is 17 meters. All right, now let's go on to part B. Find the magnitude and the direction of the displacement of the object. Now, if you guys recall earlier, one of our key terms was displacement. Displacement is the distance from the starting point to the ending point. It doesn't matter what you did in the middle. Displacement is only concerned with your start and your finish. So here we started at point A and we ended at point C. So our displacement would be exactly from A to C. And how much is that? 9 kilometers. So our displacement would be 9 kilometers. And let's say the direction is east. And that's our displacement. Part C. Find the time it took for the object to complete its total travel if the object moved at a constant speed of 5 meters per second. So, let's examine the keywords in this part of the question. We need to find the time, that's what we're looking for, it took for the object to complete its total travel. So the question is saying total travel, which tells me that I'm going to need to use the distance. And we found out that before the distance equaled 17 meters. So find the time it took for the object to complete its total travel if the object moved at a constant speed of 5 meters per second. So we know speed is equal to 5 meters per second. What we need to find out is time. So let's use our distance formula. Distance is equal to speed multiplied by time. Do we have the distance? Do we have the speed? If yes, then we can find the time. So let's plug in our numbers into our equation. 17 is equal to 5 times t. Now, we need to get t by itself with no coefficient in front of it, so we're going to divide by 5 on both sides, and then we'll get t is equal to 17 over 5, which is also equal to 3.4 seconds. And here's your final answer. Great. Now, let's graph this problem. First, we'll do the distance versus time graph. We'll have time on our x-axis and distance on our y-axis. Now, if you recall, we just found out that the distance is 17 kilometers and this time is 3.4 seconds. So now let's graph this. 1, 2, 3, 4. So 3.4 is somewhere in the middle between 3 and 4. So let's call it the middle right here. 3.4. And on distance, we need to go up to 17. So let's count by 5s. 5, 10, 15, 20. So if this is 15, 17 would probably be somewhere right here. Okay. Now let's find 3.4 and let's see where these two lines intersect each other. So now I find that point, 3.4 on the x, 17 on the y, and I'm gonna make a straight line from 0 to that point and I'm gonna connect it. So as the time increased, the distance increased. Now let's go to the speed graph. The problem told us that it traveled at a constant speed of 5 meters per second. So the speed was 5 kilometers per second, right? So all we need to do is go on our y-axis and find 5. Now the problem said constant speed. So what does that look like? A straight line at 5. So the speed did not change for the whole entire time, as you can see. That's why there's a straight line at 5 kilometers per second. Now let's try model problem number 2. From rest, a car accelerated at 8 meters per second squared for 10 seconds. A, what is the position of the car at the end of the 10 seconds? So first, I'm gonna look at what this question is asking for. It says, what is the position? From the vocabulary, I know they're asking me to find out how much distance did this car travel. So I'm also gonna examine what type of motion is this. Is this linear motion or is this accelerating motion? Key word, the car accelerated. So I'm gonna use the distance formula from acceleration motion, which is d is equal to 1/2 a t squared plus v I t. Okay, now these terms may look a little crazy to you, but we're gonna work it out together. So a here is the acceleration. The question tells us that it accelerated at 8 meters per second squared. So I know that I can substitute wherever I see a, I'll put 8. Now t. T simply stands for time. How long did it take the car? Took them 10 seconds. So we're gonna put 10 where we see t, right? Now VI. This simply means what was the speed when the car started? The problem tells us that it went from rest. Resting means that it was not moving. So the speed at that time was 0 meters per second. So plus 0, and then t again, which is 10. We know that 0 times any number is 0, so this side will be 0. Now, we have 1/2 times 8, which is 4, and then 10 to the second power, which is 100. So we know that the distance here is 4 times 100, so the distance is equal to 400 meters. Wasn't that simple? Let's try part B. What is the velocity of the car at the end of the 10 seconds? Keyword, at the end. So from the first problem, we know that it went from rest. It started at 0, but what was the velocity at the end of the 10 seconds? So we'll call that V final, since we don't know. Okay? Now, we're gonna use the formula for the final velocity, which will be on the screen. Vf is equal to Vi plus A times T. So from the first problem, we know that VI was 0. We know that A was 8 meters per second squared, and T, it took the car 10 seconds. So we multiply 8 times 10, we get that our final velocity is equal to 80 meters per second. There we go. Model problem number 3. If a 15-kilogram ball takes 5 seconds to strike the ground when released from rest, at approximately what height was the ball dropped? Okay, so let's take a minute to jot down what we know. So the ball is 15 kilograms, right? And it takes 5 seconds to strike the ground. So time is equal to 5 seconds, okay? When released from rest, so that means the initial velocity is equal to 0 meters per second, okay? At approximately what height was the ball dropped? So they're asking for height, or we can call it distance, right? So we need to use a formula that gives us the distance. Think back to the last problem. We used the distance formula. D is equal to 1/2 AT squared plus VIT. But wait, we don't have A. But what type of motion is this? Accelerating motion. Specifically, free fall. The ball is falling straight down under the sole influence of gravity. So our acceleration for this is gravity. And gravity is equal to 9.81 meters per second squared. Now we can substitute. So 1/2 RA is gravity. So put that in, 9.81. And now T, 5 squared. Now the initial velocity is 0, and we know 0 times anything will be 0. So we know that that's 0. Now we compute this. So the distance is 122.625 meters, which is approximately 125 meters. Now you can see from the answer choices that choice D is the best answer.